Good morning. So in this video, we're going to talk about finding the length of arcs around a circle. And to begin, we're going to talk about finding the circumference of a circle, and that means the entire length all the way around the entire circle. Some problems you'll be given, like you are on the one here on the left, a radius. So this 16 here is the radius. So I look to my formulas, and the one with the radius in it says it's 2 times pi times the radius. So here I'm just going to do 2 times the 16, which makes the 32. And then I'm just going to tack the pi on at the end. That's generally the best way to do it, is to leave the pi on there at the end. You could type it in the calculator or use 3.14 as an estimation, and it would come out somewhere near 100. But 32 pi is actually a better answer, and we're going to leave it in terms of pi for now. If you get a diameter like this 16 that goes all the way across, okay, then you're going to use this formula. Circumference equals pi times the diameter. So on this circle, if 16 is the whole way across, then the whole circumference is just 16 pi. And remember, circumference means all the way around and back to where you started. Okay, so now let's get into talking about actual arcs rather than the entire circle. And a track is not exactly a circle, but this kind of gets the idea across. So if Colson ran a quarter of the way around the track, that is 400 meters, how far did he run? So a quarter is 1/4. So all we want to do here is just 1/4 times 400. He ran 100 meters. Okay, this is how the calculation works. You do the fraction, so 1/4 times the total, 400, and you get the length he did run, which is 100. We're going to do kind of a similar idea with our circles. So this is your formula. We'll do a fraction out of 360, and it's either the angle measure coming from the central angle or the arc measure, if you know that, out of 360, and then times 2 pi r. This is your total circumference, is 2 times the radius times pi. So here we go. Here's a couple of examples. We want the length of arc AB. And notice there's no little m out here in front. If there were an m, it would just be 60 degrees. It would be asking for a degree measure. But without the m, what this is talking about is the length. Okay, so when we talk about length, we have to think first that we're only talking about a small portion of the circle, 60 degrees out of 360. Okay, so we do our 60 out of 360. And then we're going to multiply that by 2 times pi times radius. And 2 times 18 is 36, so 36 pi. So when I type that into my calculator, I'm going to hold off on typing in the pi. I'm just going to do 60 out of 360 times 36. And what the calculator tells me is 6, and so the answer is going to be 6 pi. I tack the pi on at the end when I'm writing the answer down or typing it in to IXL. So just do 60 out of 360 just like this, times 36. Do not type the pi in your calculator. It'll tell you it's 6. You write the pi or type the pi in next to it. Okay, here's another one. Now we have a 120 degree angle, so we got a new fraction, 120 out of 360, and you might notice that that's actually going to simplify down to 1/3. If you notice something like that, 120 out of 360 being 1/3 or 180 out of 360 being 1/2, you can use it, but I think it's going to be simpler for most of you just to focus on using a fraction out of 360. And this would multiply times 2 pi r, and 2 times a radius of 12 makes 24 pi. And if you're curious how this looks on the calculator, I can pull that up. So 120 out of 360 times 24. You'll see in just a second how I'm going to type this in. I just go 120 out of 360 and then times 24. Tells me it's 8. So I know that the answer is not just 8, but 8 pi. All right, we'll do one more that's maybe a little bit tricky. This one wants arc FG, but you'll notice if you look at FG, it's this kind of bigger arc here. I don't know the angle at the center for that one, but I do know the 45 that sits next to it, and this 45 and my angle would have to add up to 180. So I do a 180 minus 45, and I'm going to get 135. going right in here. So that's the fraction out of 360 that I want, is 135. This could be a little neater. Out of 360. And then we're going to multiply that. Let's neaten that one up a little bit. That's a mess. We're going to multiply that 135 out of 360 times 2 times pi times the radius, and 2 times 15 is 30, so that becomes 30 pi. So 135 out of 360 times 30, and it gives me 11.25. So 11.25 pi is going to be my answer. And this is basically how you do arc length. So hopefully this is helpful. This is going to tie to U.3 on IXL if you're working on that IXL assignment.